you're making a big change when you take away the combustion engine, in that the noise just disappears. Suddenly, all of those things that were quiet before aren't quiet anymore. You can hear.
We will not compromise on things like cutting the chassis. The body has to be as it is designed.
How much of that is original character, and how much of that do we want to keep? Versus, do we want to make a version which is, like a really modern car?
And I think last but not least, we are using some of the very best components available, which actually aren't available to the general public. And that's what's really, really fun for us, of course, is when we create something that people really, really want to use. And that's obviously very rewarding from our perspective.
All right, buckle up. Today we've got a duo that could make your old family hatchback die of shame. First, Justin Lunny. He looked at classic Porsche and thought, lovely car, but what if it didn't smell like petrol and guilt? So he founded Everati, taking the most iconic cars in history and giving them an electric makeover. Basically, he's like a plastic surgeon for automobiles, except instead of Botox, it's lithium ion. And then there's Doug Cross. Doug has spent 30 years building engines so advanced they make transformers look like lawnmowers. He co-founded Flybird, worked on 20,000 RPM Formula One engine that's faster than most relationships on Tinder these days. And now he's making sure Justin's dream cars don't end up as very expensive toasters. Together, they are the power couple of clean mobility, and yes, they will make your price feel, well, deeply insecure. Gentlemen, welcome.
Thank you very much.
Thank you very much. Thank you for that great introduction.
People call Everati a bridge between the past and the future. What does that really mean to you, and why now?
So I think why now is a good question. So we are essentially taking some beautiful, iconic cars that people may have had as their poster cars, maybe as a younger person, and really redefining those as an entirely new EV with a new EV powertrain. In essence, what that really means is taking the car and essentially doing what would normally be almost a new vehicle program, but on an existing chassis. So we are doing an awful lot of research and engineering to ensure that the powertrains we develop for these vehicles are suited perfectly to that application. When it comes to weight, performance, center of gravity, and indeed just the driving experience. So really what we're doing here is allowing these beautiful iconic cars to be used into the future and hopefully by generations to come.
Tell me about the moment you decided you didn't want to just, love the classic cars. You wanted to electrify them. What lit that spark?
Yeah, a couple of things really. My history is that I am a tech entrepreneur, so I've founded and sold a couple of tech companies, fintech companies principally, but I've always been a car lover, car guy, I suppose. And two things happened to me actually. So when I was I'd sold a company in around 2016, 2017, 18, I was looking for something else to do. And what inspired me into clean tech actually was my daughter, who at the time had started worrying about climate change and the earth flooding, and she was only 7 or 8 years old. So I was kind of thinking, what could I do? And then something happened very close to where I live. So I live in the UK, not far from Windsor Castle. And as you may know, in 2018, Prince Harry and Meghan were married, and they drove away from their wedding in an electric E-Type that had actually been done by Rimac. So that was kind of my inspiration. I started researching and built the company from the ground up, starting in 2019.
Wow. How do you balance performance versus weight when putting batteries into 90s, 60s, or 70s chases, Doug?
Yeah, happy to answer that. One of the things that you really care about with your iconic car is handling. And a Porsche 911 wouldn't be a Porsche 911 if it didn't lift the inside front wheel as you go around corners. And so, it's really important as we take iconic classics to weigh them first of all as they come to us, to establish what the balance of weight is and the corner weight distribution. And then, as we go about re-engineering them, we have to make sure that we stay, very close to that original weight balance and overall weight. We don't want to start changing the suspension, to make sure that the car handles in the same way that it did, and it's got the same performance and the same level of safety as it had before. And typically, for us, we're able to do that, within 50 kilos or so of the original weight of the car. In some cars, we're a little bit lighter, in some cars, we're a little bit heavier, but there or thereabouts. And the compromises that you're going through are the weight of the powertrain, and of course, partly that's dictated by the battery. And so we work heavily at making sure we can get good performance and good range, and yet the battery isn't too heavy. And so our cars are typically something like a couple of 100 miles of range, so a battery pack that's around 60 kilowatt hours. And we retain that feel and driving characteristic of the original car. Perhaps, Justin, would you like to add to that?
Yeah, no, thank you. Yeah, and it's exactly that. So it's really updating it and ensuring that we are true to the original in virtually every respect, and ensuring really it's all about the balance as Douglas described. So we do thousands of hours of engineering on each model that we do, and then we do many thousands of miles of testing as well, really to ensure that feedback is as you'd expect in that type of model of car.
Yeah. So the next question is actually for both of you, but maybe from different perspectives. Tell me about the GT40 project. What were the biggest surprises you didn't anticipate?
Yeah, I mean, first of all, the feedback we get from the GT40 is incredible. People sometimes think we've created that out of an existing original car, which of course we haven't. It's actually a GT40 that is created in combination with a company called Superformance, who have the rights to create toolroom copies essentially of the GT40, and it's in the Shelby register as an official GT40. Really, that car, as you know, is a stripped out road racer, I suppose. And getting the right performance with the right weight distribution and the right overall weight was clearly a huge challenge. In our first generation, we even used the side pods, which is actually where the fuel tanks would have been as a combustion car. And we have gone now to entirely re-engineer that such that we have a car that is actually lighter than the original, with actually arguably slightly better weight distribution. So the challenges, as always, are, these are tight packaging spaces. It's not just the batteries, the motors, it's the multiple inverters, it is the cooling systems. We have 3 cooling systems on that car, one for the inverter and charging, one for the batteries and one for the motors. So again, fitting all of that packaging into such a small space with the custom looms, both in terms of high voltage and indeed low voltage. And then some creature comforts, adding in audio, adding in air conditioning, adding in things that would have never been there before, but actually to make it a good experience and something that people want to be in, again, is all part of what we do.
Wow. Doug?
Yeah, absolutely. So some of the challenges Justin's already alluded to, that is an 800 horsepower car in the electrified version. And, you can imagine some of the challenges that come with that. You want to make sure as you increase horsepower, you don't end up with things like axle tramp. You have to manage friction at the rear tires. So, with so much torque available, electric powertrains are famously very high torque. You can easily get to a place where you can, in the right conditions, spin the rear wheels up to a significant speed, let's say 100 miles an hour. And so having a level of traction control and these are the things that are quite challenging around that car. packaging is another issue. It's a small car, and with the electrifying icon side of Everati, that's always the case. The cars that we're working on there are generally very old, and they're a lot smaller than today's cars. So trying to package something in there, especially with that kind of power characteristic, and still a decent range on it too. These are big challenges.
Yeah. So, but Doug, still, you often talk about preserving the soul of the vehicle. What technical decisions go into that? Throttle mapping, steering feel, sound.
Yeah, great question. So, in some of our cars, for example, we have Land Rover series that we sell. Those cars, we retain the look and feel of them by keeping elements of the drivetrain. So you're making a big change when you take away the combustion engine, in that the noise just disappears.
Yeah.
And now suddenly all of those things that were quiet before aren't quiet anymore. You can hear every single every gear in the gearbox. You can hear the windscreen washer pump. You can hear all of those little components that you don't normally think about. And so some of the challenges are around, well, how much of that is original character, and how much of that do we want to keep, versus do we want to make a version which is like a really modern car, and where you're trying to make it perfectly silent as if you just bought a brand new Tesla. And of course, for the iconic classics, we don't want to do that. We want to retain that character. And so there's a bit of a decision to take around various noises and vibrations and things that just normally get obliterated by the engine. And with an electric car, as you modify it, then you have to figure out what you're going to do with those things.
What battery chemistries are you betting on, and why?
Justin, that's a great question.
Do you know what? I would like to answer that. Being an in-house battery expert. So
happy to. Good one. So I have been involved in projects in the battery world for a while now. The typical chemistries that people are available to us today are NMC chemistries, and nickel, manganese, cobalt are the main constituents. And over the last 5-10 years, people have moved to reduce the amount of cobalt that's in it, because that's by far the most expensive chemical. And so where the ratio was, it's now moved to 8:1:1, so just one portion, if you like, of cobalt. And in the past it's been as high as 6:2:2. So these are the chemistries that are available today. But of course, we have our eye on the future. And so we've done work with solid state companies. So I did a piece of work with a solid state company looking to see if they were to replace the batteries in an existing baseline battery pack with their solid state. What differences would it make? Solid state batteries, they have a few characteristics. So where one is the expansion. If you think about a solid state battery, typically you've got the active material is the same, so it's still NMC. Then you've got a separator that is also your electrolyte, a solid piece. And then you've got lithium, and often it's pure lithium for some variants. And as you shuttle the lithium ions from one side to the other, you're essentially plating that lithium. And if it's pure lithium and you're plating it, then it gets thicker. And so one of the challenges you've got is these cells change shape as you charge them and discharge them. And indeed, over their life, not all of the lithium that you put in on the first time actually comes out again. So some of it gets left behind, and so over life they also change thickness. And trying to manage that, means that you have to allow for expansion in your packaging, but also in a conventional battery, you have to think about the ions are moving in a liquid, that liquid electrolyte. When you go to solid state, there is no liquid. So you've got active material on one side of your cell and on the cathode, and you've got the anode on the other side, and joining them up is just this solid thing. So how do you get the ions to move across from the active material into the electrolyte, which is solid? And the answer is, well, you have to have really close contact. And that, of course, means that you have to push them together really hard. So all of the surface roughness, if you like, gets squashed together. And so, the pressure that you have to apply to those batteries is quite high. And typically that means that you can't make cylindrical cells, which are very popular choices, particularly if you're doing variable packaging. So each of our vehicles has got a different package space, and we're dealing with lots of different vehicles and lots of different customer vehicles. So we'll need something flexible. But if you've got a big chunky cell and you have to squash it, that restricts what you can do with your packaging. So so we're looking to the future in terms of solid state. We're understanding what the challenges are with those solid state cells, and it's great to see that there are some samples up and running, but there are still challenges to be overcome. And I've seen some companies announcing they're going to be in production this year, around about now. And I look forward to seeing how they've overcome those challenges.
For sure. How do you approach safety and crash standards with cars that were, never designed for modern EV powertrains?
I'll give that one to Justin.
Yeah, I mean, look, we are, so essentially the cars that we are essentially redefining are still registered as vehicles from that model year. So it may be a 1971 Land Rover, it might be a 1990 Porsche, or a 1960s Mercedes-Benz. So the kind of ruling is that it has to still meet effectively the regulations as were back when the car was made. However, we do clearly go beyond that. So things like R100 battery safety is something that's really important to us. We do things like EMC testing across our vehicles to ensure that the EMC load is within suggested and safe limits. And then we also design all of our mechanical design fixing. So where we're, let's say, taking a mounting to an original engine mount, let's say for batteries, or original gearbox mount, say for motors and EDU, are designed to 20G acceleration and deceleration. So essentially ensuring that whatever we put in back into the vehicle is as safe, if not safer, than what would have been there in the past. However, when it comes to crash structures, we are not able, and in fact it would be against many regulations for us to alter the chassis to meet current crash regulations. So in essence, the regulations are that we don't do that, but clearly everything we put back in, we want to ensure is as safe as possible.
And what role does software play in the driving experience? How much control do you have over the mapping, thermal management, whatever?
Yeah. So we have our own VCU, our own vehicle control unit, and indeed our in-house developed software. So we're able to essentially do exactly that. So map torque inputs against clearly road speed. We have things like multiple driving modes, so eco, normal, right through to sport, depending on the application. We are also developing traction control, as in software-based traction control, and indeed torque vectoring, more for the projects that we're doing for new vehicles as opposed to the iconic cars. And really, clearly we are clearly always monitoring things like battery within the BMS application as well. So really, in-house developed software. and really just developing the functionality that you might find in a lot of new vehicles that we're then able to offer in some of the iconic cars that we're redefining as well.
Wow. So, Doug, how do you test these vehicles? What climate, load, durability conditions push you hardest?
Yeah, that's a great question. A lot of our team have come from automotive OEMs, and we have people who've worked at the likes of Jaguar and Aston Martin and many others. And if you were to go to full OEM standards, then you would end up doing climatic testing. You would go and do 2 sets of winter testing in the north of Finland. And you would test it at full speed on Death Valley, and then go and park it behind a bluff wall, so you get a maximum heat load on it. There's no chance for it to radiate heat away. There's a bunch of characteristic testing you would do, but of course that program is millions of pounds, hundreds of millions of pounds worth of testing. And for our electrifying icons, it isn't pragmatic through that. The customer won't bear the price of it. And the number of vehicles we're selling is intended to be an exclusive number. So we're not going to be selling hundreds of thousands over which we can amortize that cost. So we have to take a much more pragmatic view. And of course, the things that we do primarily are proving out the performance of the powertrain, so that it does everything that it's supposed to do, as well as proving out reliability. So one of the worst safety cases is an unintended release of energy. So if you imagine that you are sat at a T-junction with traffic going past you, and then suddenly the car flips into gear and starts driving, this is one of the worst cases you can imagine. So these are the kinds of software tests that we do to ensure that the car is functionally safe. So we have to take a pragmatic approach to it. We have all of the experience to know which of those OEM tests we should carry over and which we shouldn't, or to find a pragmatic alternative way of doing it at much lower cost.
Yeah, and I'd also add to that, a lot of what we do clearly is real world testing in terms of our own cars, but in fact, we're also doing data logging on all of our client cars. So, for example, our Land Rovers have been testing in the winter in Vermont. They're also used in Switzerland with clients. So we get not only the pre-world, the real world testing before they're delivered, but we also have that data that we're feeding back into our systems in terms of real world data. Things like climate and how they reacted both heat and cold, but also mileage and making sure we can verify that the range is going to be what it should be. So we get a lot of that data back on all of our cars that are kind of out there in the wild, and that obviously also then inputs into our further development. So it's kind of a 360-degree loop, as it were, to ensure that we're able to get that data back and make advancements and upgrade those cars in service should we need to.
Yeah. So what supply chain, material challenges are you seeing? For example, rare metals or sourcing components that work under tight packaging or shape constraints?
Yeah.
So certainly from a pure play core componentry, so things like motors, inverters, and indeed battery modules, we have a variety of partners. I would say we use very much best-in-class technology. So we're using advanced high density or high power density motors, for example. Our core partner there is a company called Helix, whose motors also power things like Formula E and various other high performance vehicles. So very, very power dense. And we have a direct relationship with people like this. We also have a direct relationship with our silicon carbide inverter partner. And again, these are products that would not normally be seen at this level of the market, but we're able to access those. And then when it comes to battery, we are really looking to be as agnostic as possible there, and utilize, as Doug said in the past, certain cylindrical cell types that are readily available from multiple suppliers, and indeed modules as we move that forward. I don't know if you want to add anything to the modular batteries piece, Doug.
Yeah, I guess only that. In terms of modularity, so we try and offer our customers a range of different things. So we find people come to us, and when they state their customer requirement, we have to do a bit of interpretation. And typically, the customer is saying something which we interpret as, "Oh, we'd really like the one you already make, but can you just modify it a little bit for us?" And so, we can offer 3 levels of development. We can sell you the one we already make exactly as it is. Of course, every new car customer that comes along and says, "Well, I'd like to develop my own 2-seater sports car, and I'd like to take the battery from your GT40 and just put it in." Well, it's unfortunate that the cars aren't exactly the same shape or size. So, whilst I'm sure customers would like that, it generally doesn't work that easily. And so, the next step then is to say, okay, well, can you take what's inside that battery? Can you repackage it to fit my package space? So, that's the next level of offering, which is customized off the shelf, if you like. And then finally, we have some customers who come to us and say, I want to build a car that has got a megawatt of power, power station numbers. And for those customers, they do exist. For those customers, obviously what we currently have off the shelf isn't going to be suitable for them, but we do have cells available to us that we can use. And so then we would offer them a bespoke battery development. So the 3 service levels, you can have exactly what we've got off the shelf, you can have customized off the shelf, or we can do a full development battery program for you. And obviously the price varies accordingly.
Yeah, of course. So, Justin, is there ever a design compromise you refuse to make, even if the cost is huge?
Look, I think the key thing so we have 2 parts to our business, which is important to say. So the combination of what we do today on the iconic cars, the key thing there really is, we will not compromise on things like cutting the chassis. The body has to be as it is designed. So very, very minimal, if at all, changes to that. And that's really important because these cars have a value as they stand. They are increasing in value as the underlying asset. So when it comes to what we won't compromise on is elements of maintaining that car's structural integrity as it was designed, and of course safety. When it comes to the new powertrains that we are designing for new vehicles, and we are getting increasingly busy in that regard, so things like developing new carbon fiber monocoque-based sports cars and various other vehicles with our partners. Really, that's down to the full vehicle program in terms of what are the requirements, both from a engineering and technical perspective, but of course also what homologation requirements are going to be placed on that vehicle once it gets on the road. So that's very much a collaborative approach with our clients to then take those potential developments forward and plan for production on those as well.
Thank you, Doug. How modular are your powertrains? Could the same system work for a Pagode SL and GT40, or are they fundamentally bespoke each time?
Well, so they're certainly not bespoke each time. As I've explained, the customers who come to us say what they really want is the one like the price of the one you already make, but make it fit my vehicle. And so the challenge that we are solving is to try and make everything as flexible as possible. So with EDUs, for example, we looked at the different types of EDU that we package in different vehicles. And there's more than 500 different variants. If you think about different motor types and then different gear ratios and indeed, different layouts. And so, we are developing our own EDU where it is fitted in the vehicle. So initially we looked at 2 motors back to back, and then small epicyclic transmissions, and then drive shafts going out. And that way you can drive each of the wheels on that axle, and it gives you a lot of flexibility. You don't have to worry about gear ratio so much. But the downside of that is it builds quite wide in the car, and of course you've got the price of 2 motors. And so some vehicles that's absolutely fine. The width in the car has an impact on the drive shaft, so it means that your drive shafts have to be quite short, and then the drive shaft life is dependent on the angle that it has to go through. So if it's short, obviously the angle is much higher for a certain amount of travel, and that means that that kind of application, that layout really is suitable for sports cars where the wheels don't move very much, but it isn't really suitable for things like 4x4s with a lot of off-road travel. And so what we've decided is we're developing our own EDU where essentially it's a differential in the center, and then ahead of that or behind that in the vehicle is a motor and a bevel gear drivetrain. And so that package is really narrow in the car, and it tends to package along the car. And we've designed it so that it can run different ratios on the same center distances. So we can run motors where the ratio between motor speed and wheel speed can be as high as 10:1 or as low as 5:1 or anything in between. It will run with the motor ahead of the axle, so a rear drive type application. But equally, it will run the other way around with a motor behind the axle, so a front drive. And that means for us that it has to be able to do full power, full speed, and full torque in forward and in reverse directions, as well as having flexible packaging, as well as everything else that goes with it. So we've really gone about developing something which is super flexible, and of course we're able to fit that in every single one of the vehicles that we make today, as well as offer it to our customers for the other side of the business, the Powered by Everati side. On the batteries, we're doing exactly the same thing. We're in the process of creating battery modules that are very flexible. We can make them in different voltages. We can make them in different capacities. We can make them in different physical shapes and sizes. If you want a triangular battery pack, we're working on that. If you want a hexagonal one or a rectangular one, no problem. So, it's about having the right technologies to fulfill those customer needs.
Amazing. Justin, what makes Everati different?
Do you know, we got asked that quite a lot, really. I think, we are, at our core, we are a high technology EV integrations business. So essentially creating, as Doug has said, very, very broad range of in-house developed powertrains that are usable for multiple applications, be that our existing B2C business, where we're developing these cars for third party, high net worth individuals, principally in the United States, and that has its own opportunities that brings, and that really for us is a fantastic shop front for what we then do as our B2B business, where we're developing powertrains for a number of new vehicle projects. So that's really what makes us different. Is I think we've now had many years experience in understanding the challenges of building a powertrain that will be safe, reliable, and indeed meet the constraints of modern usage. And certainly when it comes to things like functional safety, packaging, and indeed the software that goes with all that to make it fit together and work. I truly believe we can develop powertrains far more efficiently and in an agile nature compared to much of the rest of the industry, because we've had to for our own projects. I think that's the key thing here. So, as Doug said, hugely flexible, so up to 500 different configurations on our EDU, which is unheard of in the industry. Very, very flexible battery packaging, and indeed very, very flexible when it comes to our own software, which, because it's in-house developed, we are able to then add functionality as we move forward without then going externally to third parties. So I think we're pretty unique in that regard.
And about your business model, is it always bespoke, always ultra luxury, or do you see a path toward more accessible electrified classics?
Yeah, absolutely. So right now, the great thing about our business is that, we are approached daily by clients that might want something slightly different. And generally speaking, these are individuals that have the means to potentially fund a new vehicle development. So they, in collaboration with ourselves. So certainly we are looking towards a couple of potential vehicles that would certainly create an entry point into the Everati world that would be lower. But by definition, the biggest challenge that we face, I suppose, is that we will only do things to the very highest standards. So we do not envisage just creating, let's say, kits, because we do believe that, unfortunately, just providing a kit for a vehicle where no one's actually looked that the underlying vehicle is safe and isn't riddled with rust and all the other things that can be, is not a business model that we would like to be in. So, and therefore the cost of restoration, on something like any of the cars that we do, but any classic car, is very significant. So I think that's the key thing here is, yes, of course, we can get the powertrain pricing down as time evolves and with volume, but actually when it comes to delivering an end-to-end product to the client, it has to be right. It has to be fully restored. It has to be nut and bolt restored and perfectly safe. When it comes to our B2B business, however, as I say, that's where we're developing powertrains for others, and that allows a lot more flexibility because, again, they're not involved in the overall development of the structure and the architecture.
Doug, how do regulations help or hurt what you're doing? Emissions rules, safety laws, ICE bans, import-export homologation, whatever.
Well, we love emissions rules. Yes, that generally isn't a challenge for us. So the kind of emissions that we have are electrical noise emissions. And, as Justin said, we generally test for those in a special chamber to make sure that we're not going to switch over your TV channel as we drive past. And so. But in general, the regulations, so there have been some new regulations around the modification of classic cars, so electrification of them, and we're very supportive of those. They came out only a couple of weeks ago, and they should make our lives substantially easier. At the same time, we're keen to ensure that not just our company reputation remains intact. Reputation is super important to us, but also that the industry reputation remains intact. So as they change those regulations, we're getting involved to make sure that they're not going to do anything or not allow anything which we think is unsafe, because the risk to us is that one of our competitors does a bad job and gives the whole industry a bad name. And so, we have to be very careful that we're involved in those setting of safety standards to make sure that everyone in the industry is working safely. Homologation is always a challenge. So you asked about homologation. And one of the difficulties is there is no unified standard across the globe. So in the UK, there is individual vehicle IVA. What's the anyway, you can register your vehicle individually, have it. I think the individual vehicle assessment. So you have it assessed individually, And that means that you get an opportunity to register your car. As long as all the components you use are up to spec, then you can create essentially a kit car. When you look at other countries, that set of regulations aren't so clear. So in the States, there's a full vehicle certification standard. There are classic vehicle certification standards, and there's kind of kit car standards. And which one of those you choose dramatically affects the cost of the engineering program. And we notice that we have one client, for example, who's in India. And in India, you've got full vehicle homologation or nothing. And so they're looking to have the vehicles homologated in Europe and then ship them back to India. And that's the way it works. So it's a pain for us, but they're a common standard across the globe. But that's the nature of global business.
Yeah. Justin, what are the cost drivers that surprise people the most when building one of your cars?
I think it's a combination of things, really. So we do have a price, a guide price for all of our vehicles. So we're very fortunate. We have some of the best build partners in the world, actually, for the marques that we offer. So the Land Rover, the Mercedes, the Porsche. I think if people aren't used to this industry, again, things like full restoration can be extremely expensive, but it's expensive. It's not for everybody because it's a lot of time and effort. Things like our Porsche, we put a virtually full carbon fiber body on that car. So for front wings, rear wings, roof, ducktail, and indeed bonnet and roof if people wish. And again, that is not an inexpensive process, but the end result is fantastic. So I think people, will and do respect that is an expensive process. And I think last but not least, we are using some of the very best components available, which actually aren't available to the general public. So, it is sometimes surprising to people that a motor can cost, 30,000 euros, but they are the best, and they are actually the ones that are suited to the application. So those are the kinds of things, I guess, that I wouldn't say surprise people, but it's how we justify the cost of what we do, because it is a very, very kind of deep technical capability, but also the finished product is exceptional, and that's what people are happy to pay for.
How do you see customer expectations evolving? Are people more interested in range or in nostalgia or in status or sustainability?
Yeah, so we have a variety of clients of different backgrounds. I think the underlying theme is lots of them are from the tech industry, so they love the idea of new technology and indeed clean tech. But not exclusively. We have clients that are car collectors that might have 200 cars in their collection. We have people who are the head of their kind of industries, whether it comes to sustainability or indeed sports players. So we have people that are from all walks of life, really. Kind of thought leaders, I guess you'd call them, in their fields. They all have an eye on sustainability, certainly, but it's more about creating something that's unique and enjoyable. Range is always going to be a debate, but I think actually the reality is that they recognize that these are tight packaging spaces. You can't expect to have the same range on something that was designed in the 60s, with the small packaging spaces, and then obviously, and also manage that weight. So, in many regards, our cars are used kind of as an A to A car, if that makes sense. So it's fun drives. It might be for people's beach houses. It might be, driving around cities. We have a client in San Francisco. He uses his daily, in and around San Francisco and down to the Bay Area. You would never normally see somebody like that driving a 1990 Porsche, but he can use his every single day, and he absolutely loves it. And he uses it, far more than he would use some of his other vehicles. And that's what's really, really fun for us, of course, is when we create something that people really, really want to use. And that's obviously very rewarding from our perspective.
Yeah, the great goal. But where do you draw the line between restoration and reinvention? And has any potential client pushed you beyond it?
Yes, I mean, look, we're always trying to be in keeping with the original design. So if you look at our Porsche, it looks almost identical to a 964 turbo body. What we do is actually not use a 964 turbo as the base, however. We use the unloved narrow body Tiptronic, which are quite frankly not really the ones that people want anyway. And it's quite a regular occurrence where we'll take a narrow body Tiptronic car. It might be low mileage, and the reason it's low mileage is no one actually wants to drive it. We take it back to the chassis. It goes through that full restoration, build up as a carbon fiber wide body vehicle, and all of a sudden that's getting all the attention at Pebble Beach or at certain car events. If it had gone as its original form, people would probably never taken a second look at it. So we always try to be in keeping. If you look at our Mercedes-Benz Pagoda, for example, it is beautifully, beautifully restored to concourse standards, albeit clearly it's not a concourse car because its heart has been transplanted with an EV powertrain. We would and could go further than that, but generally speaking, our clients want that the original look, but with the modern, with the modern driving experience.
And a final question for both of you: how scalable is your business really? If demand surged, how many cars a year could you build without losing craftsmanship?
That's a great question. So because of our business model, so the way we operate is we have a core center of excellence and engineering center here over in the UK. I'm currently in the United States, but core engineering center, that is really where we do all the development, all of the testing, all of the core engineering. We then, however, have best-in-class build partners internationally. So, for example, if we talk about our Porsche, the partner we currently utilize in Southern California is able to scale, up to 100 cars plus a year. So just on Porsche, we could technically achieve that. We're not today. Our Land Rover partner, again, is able to do a substantial number in the not quite in the hundreds, but certainly north of 50 a year. And indeed, our Mercedes partner is probably lower than that. But in essence, if you take those numbers together, that's around 150, maybe slightly higher cars a year. But the great thing, of course, is because we have that distributed manufacturing model where we're using best-in-class partners. If we wanted to add, for example, another model to that, there are people out there that are very, very keen to work with us because they love the fact that we are kind of almost productionizing the restoration of these cars. So if you have, the ability, let's say, to do 10 Land Rovers in one time, that's very unusual from a restoration perspective. But if we can create that demand, of course, people are quite happy to scale. So we're never going to be doing thousands of cars a year on this business model, but certainly into the hundreds. And then, of course, on our B2B business, that's really where it gets exciting because that's where we're developing powertrains for third parties. We've got clients at the moment talking about doing 5,000 vehicles a year where we would be we will be the powertrain provider. So that's kind of far more scalable. And of course, that's a happy concentric circle because any development we do on our B2C, we're using B2B, but also the volumes that are then create in terms of our bill of materials and our cost base, we can then feed that back into our B2C bill of materials and reduce that overall cost as well.
Thanks, Justin. Doug?
Well, I think Justin said it all. So, particularly the B2B side of the business, we get all kinds of really interesting inquiries. From can we have a Megawatt Dune buggy? Can we have a uber luxury limousine? A down a mine rescue vehicle that's then got to work in an atmosphere where there could be explosive gases. before, obviously you can't run a combustion
Yeah.
vehicle. And I think the number of applications is unlimited. It's absolutely enormous. So in terms of scalability, definitely powertrain supply on the B2B side, I can see a huge future there.
Yeah. Great. Gentlemen, thank you for being my guest today.
My pleasure, thank you.
Absolute pleasure. Thank you for inviting us.